So at this time, you should already have watched the first video on simplifying complex fractions. And so before we move on to our second example here, let's just talk and revisit the procedure that we discussed. First and foremost, it's going to be important that we locate and identify the least common multiple of all the denominators. So again, in our next example, that's going to mean that we're going to take all these denominators and determine what the least common multiple of them. The next step is to multiply this complex fraction by our special form of 1, which will be that least common multiple divided by the least common multiple. Remembering to make sure that we distribute that to each of, in this case, the 4 fractions, 2 in the denominator and 2 in the numerator. And then finally, we'll go through the final simplification process of either combining like terms or possibly even reducing additional factors that might pop up. So, with that, you may pause the video at this time to go ahead and attempt the example, and then unpause the video to kind of follow along with how I attack the question. Now realize our answers should be the same, but the procedure we use might be slightly different. I'm just going to go what I feel is the most efficient way for me. So, to start, I'm going to go ahead again, and I'm looking at all the denominators, and what I see in this case is really nice is the fact that the LCMs are easily identified because each denominator is already factored. And I see that I have an x plus 2 and I have an x minus 2. That's all. Those are all the factors that I see here. So that's good for us because now that's going to make it a little bit easier because we don't have a whole bunch of different LCMs to deal with. I should say LCM, a whole bunch of different factors to work with. All right, now the next part here is I'm going to actually multiply by the least common multiple over the least common multiple. Now, you might also identify that this is our difference of squares. But I'm not going to multiply this out and make it x squared minus 4. I'm going to leave it in its factored form. So I'm going to multiply this numerator by x plus 2, x minus 2. And I'm going to multiply this denominator by x plus 2 and x minus 2. So again, what that actually means is I'm taking this numerator times this fraction and this fraction. That's what I mean by distributing it to both fractions. And then furthermore, I'm going to do the exact same thing in the denominator, such that I'm going to take this and distribute it to both fractions of the denominator. Now, the look for once I'm done here is I should no longer have a complex fraction. The reason why we're doing this is it eliminates our denominators, and we're left just with a simple fraction or a simple rational expression. So let's go ahead and take a look at this process then again. Whenever I multiply to this first, what I'm going to see happen is the x minus 2's reduce. So that's just going to leave me with x times x plus 2. Now, what I'm going to do is I'm going to actually distribute this to our second one. So I'm going to put a plus, and now I see that the x plus 2's reduce, and now that's going to leave me with 3x minus 2. So this looks good for us because now our numerator no longer has any fractions. It's just a pure polynomial expression. All right, let's go ahead and do the same thing now down to the denominator. So I'm going to take here and multiply it towards our first fraction. And again, I see the x minus 2's reduce. So that's going to leave me with x times x plus 2. And finally, multiply this denominator to the second fraction. And now, just be careful, we see that subtraction sign there. It's be minus, furthermore, the x plus 2 is reduced. So it's going to be 3 and x minus 2. Looks very similar, right? Looks almost identical. But also realize that these are actually terms, so I can't start trying to reduce anything. That's where some students might be tempted to reduce things. I can't do that just yet. Right? I have to actually multiply this out and then go through the simplification process. So let's just kind of clean this up a little bit here. Slide on up. So now I'm happy, and now what I'm going to do is I'm just looking at my numerator. All right, just going to look at my numerator here. X times x is x squared plus 2x plus 3x minus 6. So there's just my numerator. Now I'm looking just at my denominator. I got an x squared, I got a plus 2x. I'm distributing a negative 3x this time. This would be a plus 6. So you see we have a slightly different denominator. Finally, just wrap things up by combining our like terms. This would give us x squared plus 5x minus 6. This would result in x squared minus x plus 6. So right now we have a quadratic over a quadratic, and so now we actually have a simple rational expression, no longer a complex rational expression. And one of the things I'd want to do in this final step is just see, hey, does the numerator factor and does the denominator factor by chance? And so if we look at the numerator, we see that this factors into x plus 6, x minus 1. Because factors of negative 6 that combine to give us positive 5. All right, so now we might be onto something here. And then let's look at the denominator. There are factors of 6 that combine to give us negative 3. Well, unfortunately, no in this case, because if it's a positive 6, that means the signs have to be the same. Therefore, I'm adding, and I can't add factors of 6 to get negative 1. So in this case, there's nothing that reduces or simplifies any further. And our final answer was written as a quadratic divided by the quadratic. Just as a heads up though, always check your final answer because you might actually have factors that would actually reduce further.